In an era where deep space exploration is no longer a dream but a design problem, the Artemis program represents humanity's most advanced attempt to return to the moon and stay. Led by NASA, Artemis is not just a mission, but a system of systems engineering challenge involving launch vehicles, spacecraft, propulsion, autonomy, and human survival in deep space. At the core of Artemis lies the most powerful rocket ever built, the Space Launch System. The SLS delivers roughly 39 meganewtons of thrust at liftoff. Its configuration combines a central core stage and two large solid rocket boosters. The core propulsion uses 4 RS-25 engines, heritage technology from the Space Shuttle program. The SLS employs a hybrid architecture using solid boosters for liftoff thrust and liquid hydrogen-oxygen engines for efficient, sustained ascent. This combination maximizes payload capability beyond low Earth orbit. The crew travels aboard the Orion spacecraft. Orion features an AVCOAT ablative heat shield capable of handling re-entry temperatures of around 2,800 degrees Celsius. The European Space Agency provides Orion's service module, which supplies propulsion and power for the spacecraft. Propulsion for orbital maneuvers uses an AJ-10 engine integrated into the service module. Engineering priorities include deep space radiation protection and autonomous navigation using star trackers. Life support redundancy is designed to sustain crew for around 21 days. A typical mission profile begins with launch and an Earth parking orbit lasting about 8 to 10 minutes to orbit at roughly 180 kilometers altitude. Translunar injection is a critical burn lasting about 80 minutes to achieve a velocity near 10.8 kilometers per second. The translunar coast lasts about 4 days over a distance of approximately 384,400 kilometers. Navigation during coast relies on optical navigation and deep space network tracking. Artemis II uses a free return lunar flyby with a closest approach of about 7,400 kilometers above the moon. A free return trajectory provides an engineering safety advantage by naturally returning the spacecraft to Earth in case of propulsion failure. Return involves re-entry at about 11 kilometers per second and a Pacific Ocean splashdown. Mission durations vary. Artemis. I was about 25.5 days uncrewed. Artemis II is roughly 10 days crewed, and Artemis III is planned around 30 days. Advanced technologies include autonomous guidance with AI-assisted fault detection and high-fidelity star tracking. Thermal protection advances use improved ablative bonding designed for higher lunar return velocities. Deep space network communication provides real-time telemetry across lunar distances. The Lunar Gateway will serve as an orbital staging point for refueling, docking, and sustained lunar presence. The human landing system under development by commercial partners uses a Starship variant with methane oxygen propulsion and a fully reusable architecture. Engineering challenges include cryogenic propellant management in deep space and radiation shielding beyond Earth's magnetosphere. Precision landing on the lunar South Pole and long-duration system reliability remain critical hurdles. Artemis is about building the engineering foundation for Mars and beyond through thousands of systems and millions of lines of code.